everybody, welcome to the 6.8 notes. Today we're going to be talking about indefinite integrals and antiderivatives. So far we've been talking about integrals. They've always had a bound. So you've had like f of x, and then you have been going from 3 to 4, which we've been translating to this means that you're trying to find the area under the curve f of x from 3 to 4. Well, an indefinite integral is just going to be an integral that doesn't have bounds anymore. And so essentially you're finding the equation that would help you find the area under the curve if you knew where you wanted to find the area under the curve. And so this I've talked about before, but when we evaluate indefinite integrals, and then again, the phrase that is used often in place of indefinite integrals is antiderivatives. So these words mean the same thing. We always have to add a constant. So for example, the antiderivative of 3 dx is 3x plus c, and that is because the derivative of this would get us back to 3, and for example, the derivative of 3x plus 12 is 3, but also the derivative of 3x, for example, minus 15 is also 3. And so adding that c, you're basically covering your bases and making sure that you're like including the constant in your derivative. And so the other day we did just like we kind of like reasoned through some of the antiderivative rules, but today I'm going to formally tell you the antiderivative rules. So the first antiderivative rule is the reverse power rule. And so just to remember, I guess I'll do it over here, the power rule. When you do the power rule, you, like say you had 6x to the fourth power, well the derivative of that would be 24x cubed. So you take this exponent and you multiply it by the coefficient, so 6 times 4 is 24, and then you reduce the exponent by 1. And so the power rule basically has you going the opposite way. You take your exponent, you add it by 1, and then you divide by that exponent, and then you add the plus c. And the only thing that you need to know is that this doesn't work when n can't equal 1, because if you subtract 1 you get to 0, and that messes things up. So the power rule, the two steps are add 1 to the exponent, and then divide by that exponent plus 1. So a little example over here, and we'll do more examples, but the antiderivative of 4x cubed dx would be 4x cubed plus 1 all over 3 plus 1, which ends up giving you 4x to the fourth power over 4, which ends up giving you x to the fourth power. And then to check your work, the derivative of x to the fourth is 4x cubed. So as you do these problems, and also I should be adding my plus c here, but as you do these problems, you really should always know if you're correct, because if you get your answer out, your antiderivative, if you take the derivative of it, you should get back to this original. So, oh, I didn't realize I had all this space over here for examples, my bad. So try to do those real quick. I'm going to work them out, but feel free to do them in your head. So this example right here, I'm just going to write it out. I'm just adding 1 and dividing by that number, and I will get x to the fourth power over 4 plus c. Next one, I'm going to kind of do quicker, but if you try it out, you should be getting this. I did a little bit of math in my head there, because this would be 8x squared over 2, and I just divided those real quick, but that's the answer for that one. So next is the constant rule. So basically, if you're trying to find the antiderivative of like just a number, then you're just adding an x to that, and that's because the derivative of, like, for example, 10x is just 10. So like the antiderivative of 10 is 10x plus c, and that's because the derivative of this would give us 10. This next one is a combination of, sorry, this should have a dx here, but a combination of the reverse power rule. Like you'll use the reverse power rule for this one, and then you'll do the constant for this one. And so this will give us 16x squared all over 2 plus 12x plus c, and that will simplify to 8x squared plus 12x plus c. And that is the reverse power rule. Or sorry, that's the constant power rule. Okay, on to our next problem. So now we are going to go over some of the trig rules. And again, this might be something that you could reason with based on what you already knew about the trig functions. But we will do that. Oh, sorry. Also up here, this should say n can't equal -1, not +1. So sorry, n can't equal -1 because if you added 1, that would take it to 0. So fix that real quick. But going back here are just like the common antiderivative rules that you'll just memorize. So the integral of the antiderivative of 1 over x to the natural log of x is this is a little different, but it's the absolute value, or sorry, it's the natural log of the absolute value of x plus c. E to the x is e to the x plus c because it goes back both ways. A to the x, so like an exponential function would be a to the x over the natural log of a plus c. Cosine is sine of x plus c. And again, that's just because the derivative of this is this. Like, right, the derivative of this is this. Both ways. Secant squared is tangent x plus c. Secant x tangent x is secant x plus c. So you're just filling these in, and then we'll have to like kind of reference them. Sine of x is negative cosine of x plus c. Cosecant squared x is negative cotangent of x plus c. And then cosecant cotangent x is negative cosecant x plus c. And I didn't make you guys write these down, but these ones were the, I guess these are like the more popular inverse trig. So like the antiderivative of this is its anti-trig version. The one other important thing, so you're gonna have to memorize these like rules, but the most important thing to know is that the properties of definite integrals are the same for indefinite integrals. And so one thing that we need to know is there are no product rules for quotient or quotient rules for integrals. We'll talk about how we handle that later, but there's not a product rule or a quotient rule for integrals. So it's kind of the same idea of like if you had cosine of x times natural log of x, if you wanted to find the derivative of this, you'd have to use the product rule. So we'll figure out how to deal with it, but you can't say that like the antiderivative of f of x times g of x is the same as the antiderivative of f of x g of x. Like you can't take them separately, just like in the same way that you have to do more complicated things when you use the product rule. And then also same idea. So like for example, like as this problem is right now, like you don't know how to solve it. Like you cannot solve that. And some integrals are like impossible to solve without a calculator. And like here, you cannot solve this as this is right now. So when there's multiplication involved, there's either some like algebraic manipulation that we'll learn to do, or like they're actually not solvable by hand and you would have to use a calculator to estimate what the antiderivative is, or you'd have to use like a Riemann sum or something like that. But now we'll do some practice problems. So feel free to just like work through these practice problems by yourself and check your work, but we're just gonna do these. And then I'm gonna check my work like as I go. So for this one, this is multiplication and addition, so I can just find this antiderivative, and this antiderivative, and put them together. So the antiderivative of 9 is 9x. The antiderivative of negative 3x cubed is negative 3x to the third power divided by 3. And then the square root of 7 is just a constant. And then the antiderivative of cosine of x is sine of x. And then plus c. Only thing I need to do to simplify is cancel out these. To go over here, I'll check my work, and when I check my work, I'm just going to take the derivative of that. And I mean, this is a totally optional step, but on a test or quiz, if you have time, I would do this. So the derivative of 9x is 9. The derivative of x cubed is 3x squared, and then the derivative of sine x is a positive cosine, and this is just a constant. And that constant goes away. So that's what the original problem told us, so I feel good about my answer. We're going to keep moving, but pause it if I'm moving too quick for you, blah, blah. So for this one, earlier I said there's no product rule, and so like you could look at this problem and be like, oh, there's nothing to do. Well, you can handle this because you could just get rid of the multiplication by distributing. So the first thing I'm going to do is I'm just going to distribute to get rid of this multiplication so I can find its antiderivative. So I'm doing 2x times x, getting 2x squared, 2x times negative 3, I'm getting negative 6x, 1 times x is 1x, and then 1 times negative 3 is negative 3, and then I'm going to simplify that first. So I'll get 2x squared minus 5x minus 3, and then dx. I have not taken like any derivatives or anything, or sorry, antiderivatives or anything. I just know that there's no like product rule for antiderivatives, and so I got to get rid of the product then. So that's what I did here, and now that everything's simplified, there's no product, I can actually go and take the antiderivative. So antiderivative of this is 2x cubed over 3. Antiderivative here is negative 5x squared over 2. And then the antiderivative of negative 3 is negative 3x. And then I have to add that c. And I will be taking off points if you don't add the c. And you will receive a point if you remember to add the c. So that is the antiderivative of 2x plus 1 times x minus 3. Next one, same idea. It is a quotient, and so as it is now, there's nothing you can do about it, but you can manipulate this algebraically. So the first thing I'm going to do to manipulate this algebraically is, even to start off with, we can't really handle, like, so the same, I think, idea as taking derivatives is if you have something in radical form, you need to switch it into exponential form. So I'm switching the square root of x to x to the 1/2 power, so that if I can potentially use the reverse power rule, it would need to be in exponential form. And now what I'm going to do is I'm actually going to divide, because this says x to the 1/2 power plus 1 divided by x squared. So I'm actually going to divide, and when you divide by a fraction, you are allowed to split the numerator. So I'm going to rewrite this as x to the 1/2 power over x squared plus 1 over x squared dx. So I'm just doing this divided by this and this divided by this. And then I'm going to simplify too, because like both of these are now in rational form, and there's no like rule for rational form. And so I need it to be like completely simplified. Well, I guess unsimplified in exponential form. So to do that, to divide exponents, you just subtract the exponent. So this will be x to the negative 3/2 power. And then I'm going to rewrite this is x to the negative 2 power. So I'm just like rewriting things so that everything is in like the numerator position. It's a whole number. And then I'm just rewriting it with my exponential rules. So I haven't actually found any antiderivatives yet. I'm just doing the like math to set it up. Now I can actually do antiderivative rules. So x to the negative 3/2 power, I'm adding 1 to that. So that will make that x to the negative 1/2 power. And then I divide by that exponent as well. If I add 1 to this, I'll get x to the negative 1 power all over negative 1, and then I'm adding c. This turns into, if I want to simplify it, negative 2 over the square root of x. This turns into negative 1 over x plus c. And that is the answer for this one. So this one, the hardest stuff about it is like all of the algebraic exponential rules that we have to use. I think we have one more problem, so we'll do this problem next. So this one is sometimes hard to know what you're supposed to do here, but it says if f prime of x equals x to the negative 3 power. And we know that f of 1, this is information from the original function, is 3/2. Find f of x. So it wants to know, if it's asking you to find f of x, it actually wants to know c. It wants to know like what the whole original equation is, not just like what the antiderivative is, and that's where this piece of information is going to help us. So to get anything about f of x, I need to start by taking the antiderivative of this function, because the antiderivative of f prime of x will get us back to the original. So I'm taking the integral of that. That'll give me x to the negative 2 power over negative 2, which equals negative 1/2 x squared plus c. Should have added my plus c. I'm getting points off. So far, what we know about f of x is that it's this function. But we don't know what c is. But I also have this piece of information. So what I can do is I can plug in, I know that f of 1 equals 3/2, right? Which equals 1 over negative 1 over 2 times 1 squared plus c. 3/2 then equals negative 1 over 2 plus c. I will add 1/2 to both sides. We can write this. I will get 4 over 2 equals c, which means 2 equals c. But I'm not done because I have to write my final answer. But I know that 2 equals c now, and so my final answer is negative 1/2 x squared plus 2. And that is my answer. And we are done for the day, but these are some pretty popular problems that you do sometimes. So, okay, have a good day. Goodbye.